Hey guys, and welcome to the school station. Today's video, I'm going to be talking about Group 7 of the periodic table halogens. This is from the AQA GCSE Chemistry 91 paper from the unit Atoms, Bonding and Moles. Today's video, I'm going to be talking about Group 7 of the periodic table halogens. In my last video, we talked about Group 1 of alkali metals, and now we actually have to talk about another very important group in the periodic table, which is halogens. So before we actually get started with the video, let's just have a look of the group itself. So halogens actually have only five elements, and this is actually meant to be group 7, so I'm sorry about this, but group 7 halogens actually have 5 elements, and this is actually, as you guys can see, fluorine, chlorine, bromine, iodine and astatine, or however you would pronounce it, but these are basically the 5 elements of halogens, and you don't really necessarily have to memorize this if you have the periodic table in the exam. So now that we actually have clarified what are halogens and its 5 elements, now we can go on and look at the properties of halogens. So first of all, let's start off with the colors of the elements. So this is something you may not have seen in any of my videos, but this is actually something you may have to memorize for the exam. So as I said, there are 5 elements of group 7 halogens, but you only really have to know the 4 colors or 4 elements colors. So fluorine is actually a pale yellow color, chlorine is yellowy green color, bromine is a reddish brown color, and iodine is dark purple color. So you may want to pause this video and maybe take a note of these, because you may have to memorize this for the exam, because sometimes it is mentioned in the exam for you to actually write down the color of the element and actually know how the element looks like. So definitely you can pause this video and you can just look at these elements and try to memorize it. However, if that's not necessary, we can just go on to actually the reactivity of the elements. So the elements actually have the reactivity, and the reactivity decreases going down the group. So I don't want to confuse you with the alkali metals, but in alkali metals, the reactivity increases going down the group, so it gets more and more reactive as you go down the group. But in halogens, as you go down the group, the reactivity decreases, which means that fluorine is more reactive than astatine. So therefore, this is something you'll have to know. Reactivity decreases going down the group. And the reason why this happens is that the atoms of each elements gets larger going down the group. So as you guys can see, obviously you will know that fluorine has more atoms than astatine, which means that they will be more reactive because it has more atoms, while is more reactive because it has less atoms, while astatine has more atoms but it's going to be less reactive. So the atoms of each element gets larger going down the group. This also means that the outer shell gets further away from the nucleus and is shielded by more shells. So basically what happens is that obviously in fluorine you will see that the outer shell is more closer to the nucleus of the atom, while in astatine, since there are many more shells, you will realize that the electrons in the outer shell will be more farther away from the nucleus, and because of the inner shells within the nucleus and the outer shells, so between the inner shells between the outer shell and the nucleus, this kind of shields the electrons getting to the nucleus, which means that it will actually make it harder to attract another electron to complete the outer shell. So when the outer shell is actually farther away from the nucleus and shielded by more shells, it makes it harder to attract another electron to complete the outer shell. So therefore this means that the reactivity will decrease going down the group. So now that we've talked about reactivity, we can now go to diatomic molecules. So we have to know that halogens are diatomic molecules. So what does this mean, you may wonder? It basically means that halogens elements actually need one more electron from another atom to form a single covalent bond. So what this means is that you will see that, for example, as I said, halogens, you will see that fluorine always has in exam papers F2 with a small 2 next to it, and this is because halogens are diatomic molecules, And this is because all halogen atoms require one more electron to obtain a full outer shell and become stable. So in alkaline metals, we realized that there was one more electron. So what they do is that they just cancel it, they just lose that electron, and then they become a stable electronic structure. But in halogen atoms, they just need one more electron because, 7 electrons in the outermost shell. So they only need one more to make it become 8 electrons which in the shell, which is the limit. And they actually will be able to obtain a full outer shell, and this also makes them become stable. So because they want to become stable, they actually share that one electron with another to form a single covalent bond. So by forming a single covalent bond, they make the outer shell full, and this makes the molecule stable, and this makes a diatomic molecule because they formed a single covalent bond. So that's basically how you are talking about halogens. So another property of halogens is obviously their melting and boiling points. So the group 7 elements have low melting and boiling points. And going down the group, their melting points and boiling points get higher and higher. They increase. So again, if we go over here, you will see that they basically increase going down the group. So fluorine will have a low melting and boiling point compared to a statin, which has a higher melting and boiling point. Okay. So that's basically the melting and boiling points. So they increase going down the group. And now we have actually reached the position to actually talk to you guys about the rule of halogens. So the rule of halogens is that a more reactive halogen will displace a less reactive halogen from solutions of its salts. So basically what this means is that, as I said over here, reactivity decreases going down the group. So this means that, again, fluorine is more reactive than a statin, okay? So since we know this information, we also have to say that basically fluorine, if there was a reaction, you should say that fluorine would displace a statin from solutions of its salts, and this is because fluorine is more reactive. So the more reactive halogen will displace the less reactive halogen. And if you actually can remember this from from maybe the start of secondary school, you may know this as displacement reactions. And displacement reactions are basically reactions that kind of displace one element from the other. So in this example, we basically have chlorine plus potassium bromide, which makes potassium chloride plus bromine. So over here we can see that the two halogens in this example are obviously chlorine and bromine, okay? So we can see that, as I said, reactivity decreases going down the group. So this means that we have chlorine, which is more reactive than bromine, and since a more reactive halogen will displace a less reactive halogen, what kind of happens over here is that you'll basically be able to see that the chloride takes the potassium and the bromine gets left over because the bromine is actually less reactive than the chlorine. So basically, since chlorine is more reactive than bromine, the chloride takes the place with potassium, and bromine gets left over. So that's basically what you would call a displacement reaction. So I hope you guys have understood that a more reactive halogen just takes the place of a less reactive halogen. So I want you guys to pause this video and have a go at this question. This is bromine plus potassium iodide, so you may want to use the help of a periodic table to actually do this. So just know the group. So I'm just going to go back to this group. So I want you guys to pause this video and just kind of write this down in a piece of paper, and then I'll take you to the group so that you'll be able to see which is more reactive and which is less reactive. Alright guys, hope you guys have wrote down the question, and now I'm going to go into this side over here. So this is halogens, and you guys can see this is the group. So again, you can just see which is more reactive and which is less reactive. Alright guys, I hope you guys have tried out these questions, and now I'm going to go on to the answer. So here is the answer. You should have got bromine plus potassium iodide makes potassium bromide plus iodine. The reason why is because obviously we know that bromine is more reactive than iodine, which makes the more reactive halogen displace the less reactive halogen, which means that bromide takes the place of iodine, so it becomes potassium bromide plus iodine, so iodine gets left over. So that's basically what the rule is of halogens, and you should definitely try practicing more displacement reactions because these will really help and this may come up in your exam. So I hope you guys have actually enjoyed this lesson, and I hope that this helps you. Just to go as an overview of what we have learned today, we have learned what halogens are, and we've also learned the colors that are for each element, which I would definitely advise for you guys to memorize. We've also learned the properties of halogens, which are obviously the reactivity that it decreases going down the group and the melting and boiling points increase going down the group. And we've also learned the rule of halogens, that a more reactive halogen will displace a less reactive halogen from a solution of its salts. And last of all, we've also understood how to solve questions involving displacement reaction. Just remember to always look at your periodic table, see which is more reactive, see which is less reactive, and go from there. And sometimes you can even get trick questions where they will actually already have the end result, which is a more reactive halogen already has the place, and it will sometimes not be a reaction. So look out for those and try to do more displacement reaction equations. So I hope you guys have enjoyed this video. Give it a thumbs up and subscribe down below for more free science and maths lessons from the school station. Bye guys!